Okay. Hi, everyone. My name is Guanning from Aurora Studio from Tencent, the Moonlight Blade engine group. Currently, I'm in charge of the Moonlight Blade related, the mobile and engine. I was supposed to be there on site with all of you, but suddenly my residential just got blocked. So I have to stay home and do this online. And today my topic is how to be Vulkan and GPU driven when developing Moonlight Blade Mobile, the relevant technologies and explorations we had. Moonlight Blade Mobile, we started developing it since 2017, and I personally joined Aurora Studio, the Moonlight Blade Mobile project group, and after 4 years of development, by 2022 October, by 2021 October, it got officially launched. And in mobile MMORPG, in terms of the product performance or the technology wise, it got some really nice reputation there. So, what is an MMORPG? It's a pretty complicated type of games with a massive number of players being online together at the same time and with a lot of gaming features of its special kind built within. And Moonlight Blade Mobile, it is coherent with the PC and terminal version with the same IP, which had been very successful on the PC end, and we hoped to have some better graphical performances on mobile end as well, to see those textures and the renderings and the better details with the character models and the scenarios, which means we must have some better explorations in terms of engine technologies, and these are the driving forces behind us and made us a lot of number ones in the industry when the game was launched. For example, we were the first one to fully support Vulkan on any uh, large scale or large type of mobile and MMORPG games. And when our game was launched, it actually have impacted to the or propelled the mobile games development and technologies within the industry. Let me speak about our use of Vulkan. Vulkan is a new generation API when compared with OpenGL. Yes, it's designed to support multi-threads, and its driver layer is light with very low CPU consumptions, which guarantees better performance. But most importantly, on the mobile end, the consumption is lower as well. But it requires a lot of more designs on the application layer, memory management and resources, assets, validations, etc. These are the things which made the game development process become more challenging when using Vulkan. So when developing Moonlight Blade Mobile, in this case, we have actually compared the GLES versus Vulkan quite a lot extensively. For us, we can find that the CPU load is reduced by 20 to 30%, as well as GPU memory usage, and the energy consumption got reduced quite a lot, but the compatibility issues or the development difficulties increased quite a lot. We have invested quite a lot of headcounts into that and encountered quite many issues. And why, when the project started in 2017, we had been paying attention to Vulkan, even though at that time GLES was the mainstream. Vulkan's popularity among mobile end was pretty low at that time, but we considered it and restructured the basic architecture for the rendering architecture. When you have over 1,000 draw call on mobile, and at that time the IHI thread would have a huge load. And after profiling, we found that the GLES has been consuming too much resources in terms of performance validation, and it becomes quite natural for us to introduce Vulkan into our project because it solves the issue with IHR, which had already become a bottleneck for GLES related development. At the same time, we also had seen that Vulkan will provide us with more technological possibilities into future. And we do anticipate that the hardwares on mobile ends are going to iterate and upgrade pretty fast in the near future. And Vulkan will definitely be a direction in the future. That's why, as early as in 2017 and 2018, we have been investing in development with Vulkan. And when the game finally got launched, Vulkan's penetration rate across 70% across all Tencent mobile games. And Vulkan got used by 93% of mobile devices which are running Moonlight Blade, so that it means most of our players can see how Vulkan helped them to see better performances in gaming experiences. And when developing with Vulkan, we have done quite a lot of things, such as in memory management. At the very early stages, Moonlight Blade Mobile runs in a 32-bit environment, and all of our resources and assets allocation on very small texture would have to be done on the system level, which causes to have a large number of memory fragments. And that means at that time, after running for some time, the mobile game would see out of memory because there are so many memory fragments, causing that it's unable to allocate new large blocks of memory resources. But using Vulkan, we can have a simple memory allocation locator. So for textures, it's 8K per allocation, and for others, it's 1 megabyte per allocate, and the efficiency got more than 70%. And with that texture allocator, we don't see out of memory situations anymore because its memory management performance is pretty good. And also another thing, which is often used in Vulkan development, which is descriptor set cache and the pipeline cache. For MMORPG, the pipeline cache, we have a lot of textures, types, and the PSO numbers is also very high as well. With Vulkan's support, we started another new thread to specifically work on pipeline cache management, which really helps to warm it up and reduced the lags on mobile and games. And the architecture on mobile is entirely different from PC end. The unified memory architecture means all the memory are on the main cache. It doesn't have that the GPU specific memory. So the resources are very precious, and we have done quite a lot of optimization to reduce the bandwidth consumption. For example, removing staging buffer and a merge, or remove the unnecessary render passes, and design and define the RT load and the storage. This can reduce the usage of bandwidth, improve the performance, and reduce the heating of the devices as well. There are things we could do furthermore afterwards: multi-thread, assets management, and resources loading, etc. These are the things that we are going to do furthermore in our futures. And when developing with Vulkan, apart from the performance improvements, there had been quite a lot of issues, especially the GPU Han problem. If we have a misuse of resources, it would cause GPU harm. And GLES uses a lot of driver layer codes to help you validate and check for these problems. So these problems simply wouldn't be seen in a very high frequency. But when it comes to Vulkan, these issues would occur for the developing team to deal with, and we have done quite a lot of those to solve the problem and do the GPU Han tools to help us to allocate or to find out, to locate such issues. But it's still a headache to all of us. And now that we have other tools to identify the GPU Han status, I believe this is the part that when in gaming development, we need uh, the tool suppliers could give us more support in those regards, providing us with better tools. And now I'd like to talk about how to be GPU driven when doing our development. Why we use GPU driven? Well, when comparing GPU and a CPU, they are completely different hardware architecture design. The GPU has more throughput and its deployment is simpler than CPU with the complicated threads, switchings, and anticipations. The basic function of the GPU is to highly efficiently uh, draw that and compute. The computer shader is also now widely used in gaming development. A lot of the graphic performance could actually be improved in terms of many features in order to achieve better performance. And using GPU driven, it helps us to make it into a more mainstream concept because we can use the indirect draws and the GPU driven rendering to connect all the GPU pipelines, which saves quite a lot of consumption, especially in between the GPU and the CPUs. We don't need those trips anymore.
And now with the hardware developing in cell phones, so now GPU and CPU, GPU is developing quite fast, and CPU gets somehow left behind. Starting from 2015, we can see that in GDC we do see a lot of GPU driven articles, and for ourselves, in 2018, our Vulkan version stabilized, and for the cell phone GPUs, the performance were improved quite quickly. So we hope that we can try the GPU driven on the cell phone, and that can provide us with better optimization outcome and also the low balance between CPU and GPU. Then for our game, uh, we use it for terrain and grass, and then we use for class and cluster culling. First, let's talk about the terrain, GPU driven terrain. And this is a table of the GPU driven terrain and CPU driven terrain. So you can see that in culling and in LOD algorithm, the CPU terrain, limited by the performance, we can only do the frustum culling. On GPU, we can do frustum culling or occlusion culling. And in LOD, it's also more effective. In CPU, we can only do according to a distance, and on GPU, we can do distance and complexity. We can calculate the LOD for each sector. So the result is that when it goes into the graphics pipeline, the number of vertices is largely reduced, and basically it's like 1/3 of the CPU. So that's a great improvement for the GPU performance. In the earliest days in 2019, when we started the GPU driven terrain, we actually referred to Far Cry 5 in GDC 2018. There was an article about it, and for Far Cry 5, it was a massive world, 10 kilo by 10 kilo, and they used 64 by 64 sectors, and they used the dispatch tree to manage the whole thing. So they used the compute shader to uh, spread the quad tree and to form the LOD map and then do the rendering according to the map. And in the Moonlight Blade, we used the Far Cry 5 algorithm and had the implementation, but the complexity was very big. And the other thing is that with Quad Tree, we managed the scene from top down. The outcome is that for each sector, when compute the LOD, the complexity gets passed from bottom up. So for a sector, if it's complex, but actually the surrounding sectors are very uh, not complex, then they should use LOD. But since we use Quad Tree, the nodes surrounding it, the complexity will also increase. But in the Moonlight Blade, our terrain is not that big, 2 kilo by 2 kilo at the most. And we used the sector of 32 by 32 meters. And we think that since we have 64 by 64, if we use the compute shader to parallel all of the sectors, I think it's more effective. And only when the players pass the sector, we need to do it once. So that's not a lot. And after calculating the LOD, based on that, we do the occlusion call. Then we will get the terrain mesh that we need to do rendering for. And the overall performance will be much better. But there's still a problem. Like for example, when we try to calculate, normally we use 8 renderings to get the hazard depth buffer, his depth buffer. But on the mobile GPU, the overhead is quite high because for 8 renderings you need to load, start, and so on. It's quite consuming, so we changed it to a simpler version with 2 compute shader dispatch, and each time we calculate 4 lines, and then we get the his depth buffer. So on iPhone 8 Plus, we can save 1 millisecond, and you can see that the GPU-driven terrain simplified the process. The CPU performance got better, and also the time spent on GPU is shorter. So GPU and CPU through the GPU terrain, they both got optimization. Then the during the development of mobile GPU driven, we noticed a lot of rules. So the limit of the thread is 256, and also sometimes for iPhone 6s it says 64. So we need to look out for the limit of the hardware, and also we need to look out for the memory, because the unified memory of the cell phone, we have to reduce the read and write on the storage, and we need to think about shared memory or GPU pad to cache to improve the hit rate of the GPU to improve the shader performance. The other thing is that for the algorithm, we need to be more data oriented to change our algorithm to more parallel so that on mobile we can get better performance. And based on that, we started to do the cloth, and we want to move that onto GPU. So the first stage is about the simulation. It's still done on CPU. After that, we will get the result transferred to GPU so that we can get the mutex buffer calculated on the GPU, so we can save the bandwidth as well as improving the performance, and also we can solve the problem of synchronization of CPU and GPU. We can save a lot of memory.
这是我们目前的
And
一些测试数据。
here
对于
is
一个
the
十五
test
系
data
统的
for a
目标来
10K
说，
vertices cloth.
它在 CPU 上差不
On
多能
CPU,
节省0.8
we
毫
can
秒以
save
上的这种性能。
0.8 millisecond.
它在 GPU 上
On
现在的
GPU,
消耗是
the
0.3 毫秒，但其实这
overhead
个
is
我们
the
也
the
是做了
consumption
很
is
多优
0.3
化之后，
millisecond.
最初
So
其
we
实
already
实
did a
现了
lot
一
of
个简单的
optimization.
调整。
So
因
at
为
first we
GPU
had
上
the simple
本身
version.
这个消
On
耗大约
GPU,
是
compute
0.2
shader
毫秒。
consumption is
那我们经过
1.2
profile 之
millisecond.
后，发
After the
现其实
profiling,
大
we
部分
found
情
that
况还是
in
来
most
自于
cases
内存的
the
不协。
thing,
所以我
the
们
impactful
做了
thing
很多
is
的
the read and write
优
on the
化，
memory. So we did a
减
lot
少
of
了必
optimization.
要的内存
We
不协，
reduced
然
the
后
unnecessary
去
read and write.
比如说一个
And
thread 原
for
来
example,
只
for a
需要读
thread,
3个比
it
例算一
needs
个三
to
角形，
read
那我们现
3
在
vertices
变
and
成一个
calculate one
thread
triangle.
只
Then
读
we
4个比例，
get one
两个
thread to
相邻三
calculate
角形，对，提
4
升开始
vertices
利用
to
率，并且把
calculate
算
two
法进行了
adjacent triangles
优
to
化，
improve the
算
hit
法
rate.
变得
To
更加
so we
立体。
improved the
但是
algorithm
通过
to make it more
五
parallel.
六次就开始
So
来
in the
完成
past
这
we
个动
need to
作，
use
我
like
们
5 to
通
6
过
dispatches,
一些
but then
单位
after
制的
the
方
optimization,
式去把
we
它
can
优化成一个
make
dispatch，
it
并且进行
into one dispatch
就最
parallel.
终目前的
So
效果是在
currently
GPU 上
the
0.3
result
毫秒，
is
但是这
that
个我们
on
觉得
GPU
还
it's
是继续可以
0.3
再优化
millisecond,
空
but
间的。
we think that there's still room for
另外，
optimization.
我们也在
Then
Option Culling
in
这个
inclusion
方
culling,
面，Cluster Culling 这些方面
in
做了一
cluster
些尝试。
culling, we
先要求
did
由
some
原本的
we
Option
made
Culling 是
some
在
attempts.
CPU 上做，我
So
们
back
使
then
用的
for Moonlight Blade, it
非常
was
不节省
done
的
on
MOC 计
CPU,
算法。
and then we
大
do
约
the
是1万个 million 的
use the
1万 million 左右
pre-computation
computer，
MOC. So for
计算的时间是在
10,000
0.5到1.5毫秒这个
facades
这个
or side
嗯
triangles, we can
那
do
我
it
们
in
对
0.5.
Cluster Culling 和
And
Rendering
then
的
for
方
the
式做了很多
cluster
的
culling
尝
and
试，希望
rendering,
用
we
这
did a
个
lot
方
of
式
trials,
未来
and
去
we
替
hope
代
that
CPU
we can
上
use
面的
this to replace
Operation Culling。
the
那
inclusion
我们
culling
其实
on the
做
CPU.
很多的分析，
So
想
actually,
知
we did a
道
lot of
像
analysis
Cluster Culling 这种
for
方式
cluster
在
culling. We wanted to
mobile
know
上它
that
的
on the mobile,
究竟有没有优势？
is
优
there
势在
any
于哪里？
advantage if we
我
do
们
it,
也跟
and
厂商
where
合作，
is
做
the
了一个数据
advantage?
上的 breakdown。
So we did a lot
最
of
终
data
首
breakdown
先
with
它的
the
benefits
partners.
从哪来呢？
So
那
where is the
CPU 上
benefit?
肯定
So
是
actually
有
on
很高的
CPU,
效率。
definitely
那
there can
在
be a lot of
GPU 上，
benefit.
在
Then
mobile
on
的 GPU
GPU,
上，由
on
于
mobile
硬
GPU,
件的 LRZ
since
这
the
种
hardware
技术已经
LRZ
做得非常
technology
成熟，
is
就
already
是
quite
导
mature.
致它Cluster Culling 实际
That
上
means for
在
cluster
解决
culling,
overdraw 的问题上面并没有明显的优
it
势。
doesn't really
那
help
最
that much
终
on the
进入
overdraw.
Fragment Shader 阶段
So
的
in the
恢复的数量，
fragment shader,
无论你是用
for
Cluster
the
Culling
pixel
还是直接
numbers,
用硬件的
if you use
LRZ 去
cluster
做，
culling or you use
其
the
实最终
hardware
数量是
LRZ,
差不多的。
the numbers are not
但
that
是
different.
我 Test Shader 上面还是有
But
明显的收
on
益，
the
包括
vertex
我 Test
shader,
Shader 的
it's
计算
quite
以及 binning 的过程，
lot of
都是
improvement.
有比较明显的
So
收益的。但它
actually
的收
the
益
outcome is quite
没有
obvious,
在
but it's just that
PC 的管线上面
compared to
做
the PC
Cluster Culling 收益
pipeline,
那么大。
the
所以其实
benefit
在
of the
mobile
cluster
上
culling
面
is not that
GPU
big.
上面它主
So
要是
on the
在
mobile
用
GPU,
shader 的计算的时间
it's
来
about the
换
time
取
used
vortex
with
shader 的
compute
时间的
shader.
节省。
So we can use that time
有了这
to
个
trade
这个
for the saving of the vertex
结论之
shader
后，其实我们
time
的目标
consumption.
会
So with
变得
that
更明确
target,
一些。
actually
我们希
our
望未来
aim
在
gets clearer.
那个
In the
手
future,
机
we
上
hope that
把
on the mobile
Cluster
end,
Culling 运用
we
在一
can
些
use cluster
零
culling
点数量非常大，
for
但是可
the
能材质的复杂度
scenarios
没
where
有那
there
么
are a
高
lot
的
of
情况，
vertexes,
比如
but
说
not
HRD
that
这种
complex scenario
是这
scenes,
些是
for
非常
example,
不错的选
HRD.
择。
So that would be
那
very good
其实后续
as
在
a
手机上
choice.
实现 Cluster
And in the
Rendering 的
future, if we
方式还是有不少的细节
well,
和
actually,
问题
there are a
要
lot
考
of
虑。
details that we need to
我
consider
们也还
when we
会
think
在
about the
继
cluster
续在
rendering. So
部分和
in the
技
future in open and GPU driven, we will do more attempts. So that's my presentation. Thank you.